My project is an Arduino robot with a simple chassis that utilizes basic object detection and avoidance. The focus was on ultrasonics and their utility for object avoidance functionality. A lot of robots that are capable of object detection and avoidance nowadays use a combination of sensors, including powerful LiDAR or laser sensors, cameras, and ultrasonics. But most of these sensors are generally inaccessible due to their high cost, at least for the more accurate higher-end models. So this project thus focuses on the accuracy and capabilities of a low-cost ultrasonic sensor for basic object detection and avoidance. Visible from the top view, you can see the ping or ultrasonic sensor mounted on the front. The sensor is connected to an Arduino mounted on the back, which is under the currently visible motor shield. The ultrasonic sensor pictured here is mounted on a breadboard, which is used to connect the sensor toward the Arduino. The 4 wires are for 0 voltage ground, echo pulse output, trigger pulse input, and 5 voltage power source. The ping sensor's input pulse time and triggering distance can be adjusted in code, which essentially means the programmer can decide when the robot is close enough to react to its environment or an obstacle. Due to the project's focus on ultrasonic sensors, the sensor's reliability and capabilities for long range were tested. This ping sensor's range is 2 to 400 centimeters, and testing proved it to be quite accurate. In this particular test, the ping sensor is visibly triggered when the wheel starts to rotate in the opposite direction. The sensor's triggering range was set to 200 centimeters in this example, but in other tests, there was little difference in triggering time when the range was set to, say, 4 meters. The other parts of the robot include a motor shield, which is just a driver module for the motors, an Arduino, and basic connections to an on-off switch and a battery power source. The first test showed pretty quickly that the right motor was not quite at 100% and had noticeably less torque than the left. After a couple adjustments, the robot was able to move more or less straightforward. Giving the robot a basic maze-solving algorithm, we can see the ultrasonic sensor at work. This concludes my project video. Thank you for watching.